In this video, we're going to take a look at one last polar curve, and then we'll do takeaway 17, the summary of the important polar curves that we've seen. So the last polar curve that I want to show you is called the cardioid because of its heart-like shape. So this is one example of a cardioid here that you need to be familiar with, although you don't need to know how to graph them unless you make a table of values or use the arc. You don't have to memorize the equations of them. Use the arc, what I mean is use the arcs on curves like we did in one of the previous videos. So let's look at takeaway 17, some of the important curves that we have seen. So we saw theta as a constant, and what that was a graph through the origin with an angle here of theta naught, and so that is a line through the origin. And then we also saw r is equal to a. That was a circle centered at the origin with radius a, like this. We saw 2a cos or sine theta, one of them, and it is a circle. Let me get my circle over here and I'll move it. The cosine is on the x-axis and centered at a and radius a, so that goes from 0 to 2a, centered at a and radius a. The sine version, 2a sine theta, is the same deal, but on the y-axis. So it's centered at a on the y-axis and radius a, so it goes up to 2a as well. R is a secant theta. That we saw turned out to be a vertical line. A vertical line which corresponded to the line x is equal to a, so that's going through a there, a vertical line. And then we saw roses. Roses have equations. R is a sine of n theta, or r is equal to a cos of n theta, where n is a natural, a counting number. And cardioids like the one above here have equation. R is equal to a times 1 minus cos theta if it's oriented left and right along the x-axis, and r is a 1 minus sine theta if it's oriented up and down. So these equations, the ones here that I have graphed, you have to know and know how to graph given their equation. The roses and the cardioids, you should be familiar with the shapes that they take, but I don't expect you to have the graphs memorized. If you need to graph them, you can do them by making tables of values or by looking at arcs on the function curves like we did in a previous video. That's the end of polar curves. In the next video, we're going to start using polar coordinates to evaluate double integrals.